Okay. So the primary challenge of benefit cost analysis is uncertainty. Right? So, for example, if we look at, let's say, a policy on climate change, right? And here's the trade off: how much economic production should we sacrifice to prevent damages caused by climate change? Now, we understand the science of climate change pretty well, right? We know that economic activities will cause the CO2 concentration to increase, which then in turn cause a global temperature to increase. Then this will increase severe weather conditions, which then results in economic damages such as wildfire, storms, floods, etc. Right? Now, we understand the cause and effect this really well. However, the estimations between each step, right, is really uncertain. So, for example, let's just take CO2 concentration and global temperature. For example, now this is a report, a simulation done by the IPCC. So in chapter 13, we will talk more in detail about IPCC, the Intergovernmental Panel of Climate Change, and their research. But for now, let's take a look here. Like, so for example, what this is showing us is at 450 parts per million through computer model simulation, right, we can expect anywhere from a 1 degree Celsius temperature increase to all the way to a 3.8 degrees Celsius increase. Now this black bar here, that is the 95% of the model simulations. And so what we see here is a very wide range of temperature increase, and even just half a degree will have a significant difference in the economic impact of due to severe weather change. And so when you have such a wide uncertainty, then how do we make economic decisions? How do we make how do we decide whether or not to fund a particular proposal for climate change, right? Here's another picture, right? In the classroom on textbooks, we can draw the supply and demand and make an assumption, make some simple assumptions to get one static equilibrium, and we call that the efficient outcome. However, in reality, right, we have a range of supply and a range of demand curve, which then results in a range of the efficient outcomes. Okay, so this is a challenge. We do the best we can, but it's important to be aware of uncertainties whenever we do cost and benefit analysis. Second issue: estimation of social cost is the social benefit in the cost and benefit analysis. Right? So, for example, how much does it cost to protect the rainforest? Now, that part is actually relatively easy to estimate. Right? However, how much benefit does the resource generate? Right? Is it worth it to save the rainforest? Now, that is much more difficult. And the main reason is because people have different values for natural resources. Right? So think back in chapter 6, where we could have different valuation techniques, but ultimately, economic value depends on individuals' willingness to pay, and that is a very subjective idea. Right? And if the value is not high enough, so to whoever is doing the analysis, then it might not justify the cost. Okay, and finally, discount rate. Right? Higher the discount rate, that means less investment for the future, more resources used today. Lower the discount rate, that means more conservation and investment because the future cost is weighted more heavily. Right? Now, discount rate is going to impact greatly on whether or not a project is approved or done. Right? Now, if you look at these three, for example, like just three kind of generic, politician, mega corporation, average person, who do you think will have the highest discount rate? Right? I would say politicians, right? Because politicians, right, they rely on, they worry about re-election all the time, right? So politicians actually, just by the nature of their work, they have they're operating at a much higher discount rate because they need to see return, they need to see results immediately, so that they can get re-elected. Right? Even for an average person, right? There's a limit on how far in the future an average person can plan. Right? You can imagine an average person, maybe they can plan for what happen for their grandchildren's education, but there's a limit there. Most of us don't plan for that long. However, large corporations, mega corporations, actually is actually will operate or will make decisions based on a much lower discount rate. Right? These large companies such as Royal Dutch Shell, right? They've been around for 100 years and they like to be around for 100 more. And this is why you see the majority of the renewable fuel research is done by oil companies. Right? They know more than anybody that oil is running out, and they would like to stay profitable well into the future, well after oil has been depleted. If we simply take a look at this cost and benefit analysis we saw earlier, what we can see here, for example, at here, right, the benefit estimate, the difference between using a 7% discount rate and a 3% discount rate is about 6 million. Okay. All right. Now, what does that mean? Can we infer without reading the entire proposal? Can we infer anything about the policy about this proposal? Well, if by changing the discount rate, if there's not big, if there's a not really huge difference between the value, what that means is that the benefit of this proposal is upfront. All right, the benefit of all of the benefit of this proposal is it happens pretty early, maybe in the first 1 or 2 years. So that way, the discount rate is not going to matter that much. All right. However, if we look at the cost, for example, right, the cost by using a different discount rate, using a 7%, the cost is 17 million versus using a 3%, the estimated cost is going to be 63 million. Now, what this tells you is this: in this proposal, right, the cost is happening much further down into the future. So discount rate. So when values are going to occur further down the future, discount rates will have a much higher impact. Right? These costs are going to be discounted much more by the 7% discount rate versus a 3% discount rate. Okay. And so furthermore, right, without changing anything, so again, everything here is the same between these two columns, 7% and 3%. The only thing that is different is the discount rate that's being used. And here we can see that if we use a 7% discount rate, we will accept this proposal because it is beneficial. However, if we use a 3% discount rate, right, then it will actually be a negative. We will not do this proposal. So this complicates things quite a bit because which is the correct discount rate? Like as we mentioned in last chapter, right, discount rate is highly subjective. Right? It really depends on the individual. Right? Every one of you will have a different discount rate because you all face different situation. You all have very different need, urgency for money. Okay. So last few words: cost and benefit analysis. It is an efficient allocation of resource. I put efficient in quote because efficiency relies on the correct information being passed through and utilized. Second, pros is widely utilized in many countries. So it is a common language. It is a common language because it provides numerical values for decision making. So it's easy. It's widely accepted, right? From the local to the national government level. And one of the major pros is it's a good way to allow environmental benefits to be considered. And so we think chapter 6, we can take environmental benefits, right, that then we can if we can extract and estimate the economic value, we can incorporate that into the cost and benefit analysis. Now the cons. Again, efficiency depends on the amount of information available in the decision-making process, right? So if there's the saying garbage in, garbage out, if the information is not there or it is not accurate, then you will not have an efficient allocation. Values, right, especially benefits, are difficult to quantify, right? And lastly, and one that's not being addressed is the discount rates are different for different people. Right? And as we just saw in that example, using a different discount rate could impact the decision by a lot.